Let's now turn to what are called rules of replacement. And unlike the rules of implication, which are essentially many arguments, the rules of replacement aren't arguments at all. They're simply different ways of saying the same thing. So, for example, our first rule of replacement is called De Morgan's rule. And if you look, you'll see the 4 dots in the middle. And what that's telling us is that what's on the left side is saying the same thing on the right side. So for our first one, the left side is saying not both P and Q. That's the same as saying not P or not Q. Below it, if we say not either P or Q, that's the same thing as saying not P and not Q. De Morgan's is an important rule, yet it's not that easy to grasp right away. One that is easier is commutivity. And what it's saying is that what's on the left side of either a disjunct or a conjunct is the same as on the right side. They're logically equivalent. So we can take P wedge Q and change it to Q wedge P. Or we can take P conjunct Q and change it to Q conjunct P. Our next one is also pretty easy to understand. It's associativity. Here we're saying if we have 2 wedges and 3 statements, or 2 conjunctions and 3 statements, we always have to identify a main operator. But applying the rule of associativity, since all are logically equivalent, we can move our parentheses and make the other operator our main operator for both the disjunct and the conjunction. The next rule, distribution, is a little more challenging to grasp. But here we're saying we can, when we have a conjunction and a wedge and 3 statements, we can distribute what is on our left side into both terms. Or vice versa, we could go from both terms on the right and distribute out there. So for example, if we have P conjunction Q wedge R, that's the same thing as saying P and Q or P and R. A great trick or device for working with distribution is to note that what's on the outside of the parentheses when it's distributed goes on the inside, and what's on the inside goes on the outside. So that every time you do distribution, you switch what's on the inside and what's on the outside of the parentheses. Again, as you work with them, it'll become easier to understand. And the final one is double negation. And it's saying that P is the same thing as saying tilde tilde P. And so we can go in either direction there. Tilde tilde P is the same thing as saying P. And this makes sense. In English, if we say it's raining outside, that's the same thing as saying it's not the case that it's not raining outside. A double negation. In fact, English instructors despise when people use double negations in the English language. Because basically, a double negation can be said much cleaner with just its affirmative. But again, here, for our purposes as logicians, P is the same as tilde tilde P. We're now in a position to begin using our rules of replacement in arguments. And indeed, we're now in a position to look at the argument I introduced at the beginning of this course. It says, our country is based on the principle of equality. If straight couples can get married, and obviously they can, then either same-sex couples can get married, or same-sex couples are not equal to straight couples. And if same-sex couples can get married, then our law has to change, state laws have to change as well. Now, if our country is based on the principle of equality, then same-sex couples are equal to straight couples. Thus, our law has to change. Here now we can represent the argument as follows, as we showed earlier, where C stands for a country based on equality, S for straight couples can marry, M for same-sex couples can marry, E, same-sex equal, T, state laws have to change, and O, our law has to change. And so it's an argument with 5 premises and a conclusion of O, our law has to change. Now again, we'll look to see where we can find O in the argument, and we can see it on line 4, and so we need to see if we can get O out of the 4th premise. So we'll start line 6 with modus ponens, as you can see here on lines 1 and 5, and that gives us E. We'll then use modus ponens on lines 2 and 3, and that gives us M wedge tilde E. We can now use our rule of replacement commutivity and switch M and E around. So now we have tilde E wedge M. On line 9, we can use our rule of replacement double negation for E, making it tilde E. We can then use on lines 8 and 9 disjunctive syllogism, and here we needed to double negate E first because on line 8 we're working with a negated E, so that derives M for us. And then on lines 4 and 10 we can use modus ponens to derive O conjunct T, and then finally we can use the rule of simplification to give us O, completing the natural deduction. Let's now look at our challenging example. Here we have an argument with 2 premises, and sometimes the fewer the premises, the more the challenge. And we have the conclusion T. We can locate T in the first premise. Now, when we look at the first premise, we know it's comprised of a wedge and 2 conjunctions. So that should give us some sort of a strategy. If we can do some simplification, we might be able to get T by itself. So let's begin. And of course, since it's challenging, that's not going to be quite so easy. The first move I'm going to make is I'm going to move or do commutivity to move N and Q to the other side of the conjunction. So now we have N conjunction Q disjunct N conjunction T. The reason I did that is so I can apply distribution to line 3. So if you look at the rule for distribution, I'm going to be able to pull out N from both sides of my disjunct. And if you remember, what was on the outside of the parentheses goes on the inside, and what was on the inside goes on the outside. So using that rule, we're going to end up with N conjunction Q wedge T by 3 distribution. Now I'm in a position to simplify and put N on a line by itself, and that's going to set me up for modus tollens on line 2. But since the consequent is a negation, I'm going to have to first negate N so that it can negate the consequent. So I need to double negation, and so line 6 is tilde tilde N by 5 double negation. And now I can do modus tollens, and that will give me tilde Q wedge C, lines 2, 6 modus tollens. With that, if you look at Rule 9, De Morgan's, I can apply De Morgan's to line 7, and that will give me tilde Q conjunction tilde C. In other words, line 7 and line 8 are saying the same things, and so for line 8 I have De Morgan's on line 7 that I performed. I can then take Q and simplify it to put it on a line by itself. And that's going to help me out because I can then also use commutativity on line 4 and move Q and T onto the left side of the conjunction. I can then simplify it, and so I'm now left with Q wedge T. And now if I have tilde Q and Q wedge T, by way of disjunctive syllogism, I can solve for T, thus completing the argument. These aren't easy, and oftentimes it may be frustrating and take more work or seem more difficult than it was here, but again, practice is what makes it easier.